Okay, this is me, Paul Lysander. So thanks everyone for just being here. And it's such a great community, the OCP community. It's really a pleasure and an honor to be in front of you and to represent Celestica in this forum. So the topic for this session, and it's really a good, I think a good order, is the openness and flexibility of SONiC. So the session is really focused on, just like Amir was talking about the enterprise, but we're going to kind of do a little bit compare and contrast between the data center and the enterprise in terms of the commonality between the two, where there's differences, and really how SONiC fits into the overall network picture. So here's the general agenda. We'll just start kind of at ground zero and kind of bring everyone up to the same level, hopefully, around the ecosystem and how things work together. We'll talk a little bit about the architecture, and then we'll dive more deeply into the enterprise feature set and so on. So as Amir mentioned, I mean, we owe a great debt to Microsoft. I mean, they championed this community around SONiC. They developed SONiC originally for their own use internally, and then they provided it to the open source community for us to consume and for us to build on, right? So there are a number of key milestones that is really part of this journey. One big piece of it is SCI, right? SCI is sort of the glue, and it's so important, and we'll talk more about that in the upcoming slides. And then the core architecture, which is containerization, we'll talk about that as well. The use of a centralized database, this in-memory database, we'll talk about that. And then SWSI, the switch state service, was really critical because when you look at it from a container perspective, that's sort of a key container in the overall architecture. We'll talk a little bit about the community growth and governance, and then we'll talk about the PENS community, which Amir talked about briefly as well. So when we look at it overall, what is sort of the key thing that is really sort of the differentiator architecturally? And one of the key things is microservices, and we'll certainly dive into that in a little bit of detail. I mean, these are lightning sections, so we can't go deeply into any particular topic, but hopefully we'll whet your appetite to maybe drill in a little bit deeper to get a deeper understanding. The SCI piece is really the glue. It sits between the hardware and SONiC, and it's really, I'll say, the glue interface, and we'll talk a little bit more about that as well. And part of that is really around inter-container communication or inter-process communication, and that really enables the isolation of components and features to be able to sort of have very feature-specific containers, and that modularity provides a lot of advantages to the overall architecture. So if you were to look at the overall architecture, it's really layered. It's almost like a cake, right? You've got these pieces that all sort of stack one on top of the other. At the very bottom is the hardware, right? That's the actual switch that you have in your infrastructure or that you're looking to deploy. And inside of that switch is a switch ASIC, right? And we have many different options. We have many vendors in this ecosystem that provide that ASIC that provides that functionality for the that switching function. On top of that, and that's what sort of colorized both red and blue, because this really sits between the two, and that's the SCI layer. That's one of the key architectural decisions that were made to be able to provide that independence. So you can see SONiC right above it. So let me kind of connect the two together. So you've got this piece of software called SONiC. It's the open source community. What is it that allows SONiC to run on so many different pieces of hardware? It's that SCI layer. That SCI layer is critical, right? So that comes from the switch vendor itself. They have that knowledge of the switch ASIC and the functionality that the ASIC provides, and it enables it. It provides that interface for SONiC to run on top of. It's so critical for SCI to be part of this overall ecosystem and architecture. So, and you can see here that from a SONiC perspective, that you can see these different Docker containers, right? Each container has a very specific function. You can think of it as almost like Unix or Linux pipes, right? You're familiar with pipes. You can, the philosophy behind Linux and Unix is that you have very specific functions deployed per command. And you're not trying to boil the ocean with a single command, but you can pipe the output of that into another command. Very similar from a Docker container perspective, is the ability to say, I'm going to implement this particular function in a container, and that's all I'm going to do. But that inter-process communication between Docker containers is what allows that interoperability and that clean interface between containers like east-west bound. And then above it are folks like Beyond Edge, which Amir talked about for orchestration. You can do things by Ansible or via Puppet or via Python, but that provides that northbound interface. And then so southbound would be GNMI or potentially CLI, but typically probably be more likely GNMI that you're going to be using from an orchestration perspective. So the control plane is critical, right? The control plane is what allows you to make the proper routing decisions from a software perspective. That's what says this is the right way to forward traffic. And so within that SONiC architecture, again, is leveraging many open source projects around things like BGP. So we've got this Zebra routing, routing manager that does some of this forwarding plane decisions and allows that integration of really important developments even within the open source community around how to implement routing functions within BGP, the BGP container. Then when you look at it from even if you wanted to do things like even upgrading certain features within BGP or within the control plane, you can do that because it's containerized separately. You can just upgrade that particular container without impacting anything else. That's a clean separation between container interfaces. So if you look at the enterprise network, looking specifically around enterprise, there's lots of parallels that you can see between data center and enterprise requirements, right? So yes, there's similarities, there's commonalities because they're both running IP, but they have different goals. And you can think of it infrastructure-wise, like if you were to compare it as an analogy with let's say, road construction. Highways carry cars, so do local roads, but they have different purposes, right? One is all about throughput. One's all about getting as fast from point A to point B as possible. The other one has more, I'll call it control plane features. You've got traffic lights. You've got ways to be able to control how traffic flows. Very similar sort of analogy applies to data center versus enterprise. So, from a data center perspective, it's all about making sure traffic gets as fast as possible between point A and point B. Whereas on the enterprise side, it's about many more layers of functionality. Like you're connecting your end users to the network and you're controlling their access and providing a way for them to get access. So it's, yeah, you're carrying traffic, but the goals are quite different. The traffic patterns, when you look at both sides of the network, they're very different. Like typically in the data center, you're much more interested in east-west traffic, right? Traffic between server functions. Yes, there is north and southbound as well. That's certainly there, but east-west is critical. Whereas typically from an enterprise perspective, you're really primarily interested in north-south traffic, right? So your user into the network to your servers and your server functions. So this is just some examples. So bandwidth, certainly very high bandwidth requirements in the data center. Yes, there's high bandwidth requirements in the enterprise as well, but it's a different scale. It's quite different. Latency, again, latency is always important in the network, but on the data center, it's a whole different order of magnitude in terms of level of importance compared to the enterprise. Scalability, both are important, but as we're seeing with AI, ML sort of designs that are coming out, way different scale numbers in the data center versus the enterprise. And similarly, security. Security is important everywhere. In the enterprise, typically, it's the user access piece of it. Whereas in the data center, you're talking about threats east-west and the ability to do zones and microsegmentation around server workloads. So from a design principle perspective, that requires different things. But again, you can see differences, but you can see similarities as well. Typically in the data center, you're talking like leaf spine, typically a 3-tier leaf spine top of rack switch. But this 3-tier also in the enterprise, right? Access, distribution, and core. So yes, there's differences, but there's also similarities. And if you work your way down into the deeper level of requirements, you can see that there's definitely similarities, but there are key differences that are being seen, as you deploy things into the enterprise. And so what we need to think about is, for example, I'll just take one example, is virtualization. Virtualization is important everywhere in the network. The concept of VLANs really came initially in the enterprise campus network, right? The ability to control your broadcast domains within the enterprise. Well, the need was also important in the data center, but it was different. It was similar but different. So VLAN became VXLAN, right, as an overlay in the data center. Still the importance of being able to segment your traffic, but the requirements were quite different and the scale is quite different. Similarly with QoS. QoS is important everywhere, but the features that are required for QoS is very different in the data center versus the enterprise. The enterprise is all about, where is QoS important? Again, is latency important in the enterprise? It is to a point, but the importance is probably more along things like voice traffic, where that's where latency and jitter are much more critical. And so you can see how it's a compare and contrast. Yes, there's similarities, but there's definitely key differences, which really leads us into the need for a working group or a set of working groups around PENS for the enterprise. And this is just only started about a year ago. It's only been 12 months since PENS started. But you can see how there's features that are required on the access side for user access into the network, right? Like .1x is an example. And then there's features around within the campus infrastructure. So things like LLDP or even PoE, which are clearly requirements in the enterprise. You don't need PoE in the data center, right? So there's needs there. And then we have folks in the audience that have been working on optimizing SONiC for the enterprise to make it a layer of SONiC, because again, there's some heavy lifting that's required in the data center. Those same level of features and depth of software is not necessarily needed in the campus. So there's a lot of activity going on in the PENS group, and you can see that there's more interest from vendors getting involved in PENS, which is a really good thing. So you can see how that whole initiative is definitely going to grow. And we've seen this even from us as one of the many vendors that are part of the PENS community. We're seeing more and more interest by enterprise customers wanting to look at deploying SONiC within the enterprise network, within their own enterprise networks. Security is critical. It doesn't matter where it is in the network. Security is always going to be critical. Now, some things, if you were to demarcate it, there's some things that are enterprise focused, like in the infrastructure side, and there's things that are maybe more on the edge side. So like, let's say user getting onto the network. So things like .1x is an example, right? But certainly infrastructure-wise, there's some features that are critical within the enterprise or within the infrastructure for deploying security features. Port-based security, ACLs, of course, are table stakes, right? You need ACL level functionality. Control plane policing, right? You don't want anyone to be able to bring down your network from a control plane perspective. So control plane level security and being able to gate what's happening from a control plane perspective is critical. The last bullet here is an important one, service function chaining. So this is the ability to steer traffic to very specific containers, to daisy chain them, to be able to implement new features and functionality. So if you were to look at that same diagram we saw earlier, and you can see that there is this additional functionality that can be added by add-on third-party containers, right? So someone could definitely implement additional containers into their infrastructure for features that are not in in the mainline SONiC distributions that are available in the open source community. And because of that microservices architecture, that abstraction layer, you can actually build on functionality, additional functionality that's not necessarily available within core SONiC features or functionality. So we're seeing many customers start to look at how to deploy their own unique capabilities within SONiC via add-on third-party containers. So it's a very interesting development that we're seeing within SONiC itself. Network lifecycle management. So, just like Amir has mentioned, I mean, it's a layer that sits above the core SONiC that is able to leverage APIs, northbound APIs, whether it be CLI or whether it be GNMI. And because of the declarative model of SONiC itself via the Yang model, you're able to use modern CI/CD practices for managing your SONiC infrastructure. This is very different from traditional OEM sort of thought process around static, just regular text files for your configuration. So that's a huge change for how to think about deploying SONiC within your enterprise, right? It's much more of a declarative model versus imperative, right? So very, very interesting architectural decision around Yang model and using the Redis database, in-memory database. That's a real-time database. Is really very, very interesting around that decision point, around the architecture that was architectural decisions that were made. So there's a whole slew of ecosystem partners around network management, and which is a good thing, right? I think that there's things that you can see that each is doing uniquely around their vision for what network management looks like. And so that gives customers a choice. In fact, many customers develop their own orchestration layer on top of SONiC, leveraging their own unique sort of needs. So the key takeaways. So there's a number of things. First of all, there's been a clear evolution of SONiC. And we've seen it in the data center around what SONiC has brought, even from an AI ML perspective for the data center. But there's also evolution into the enterprise, into the edge, right? Pens is a great example of that. There's more and more working groups around, or sub-working groups within Pens itself. The openness really lends itself to that because it is an open source model that people can be part of the community, or they can just build on it based on their own particular needs. And this enterprise focus is going to grow. Customers are looking for choice. Many have gone the journey of going down the OEM route, and many may continue down that route. But we're seeing more and more OEM vendors actually embrace SONiC as one more choice for customers to have within their own, running on their hardware. So this community, this ecosystem is just so critical in terms of being able to drive the development that's happening within the SONiC community. So there's lots of things that lie ahead, for both customers, for hardware vendors, and for the software community as well. And I think one of the key things is just to delve into it, to dive in, because it is a very active community. There's lots of ways to get involved. There's lots of resources that are available. And so really the takeaway is get involved. Get involved in SONiC. And so there's lots of opportunities to do that. I think this is a great community within OCP to make that happen. So thank you again for your time. And I'll just sort of open it up to any questions that folks may have. Okay. Thank you very much.